Okay, perfect. Yes, so I divided the iteration classes now, but I have not refactored them yet. That's still like, yeah, we still have to do that. I was too
What did
lazy.
you want to refactor about them? Or was it just deleting like empty methods, or have you done that?
Yeah,
already?
this is more or less what I mean with refactoring, right? Move everything that is common to the base class and stuff like that. Maybe even removing some classes. I guess that can also be done. So find some more common things of all these iteration classes. That's what I want to do at some point, because at the moment it's really mixed. Also, when this monitor things are called, the update and stuff like that, it's not very consistent. But for the moment, it's just splitting, so it shouldn't generate a lot of problems. Good. We have more people. That's very good. So, well, what topics do we have? Anyone has like a suggestion? I mean, there are also not like big pull requests waiting at the moment, I guess.
Yeah, I mean, well, I would like to get Tom's opinion on what I did to the MPI and the periodic communications. But, well, I mean, I can get anyone's opinion, but
yeah, I haven't looked at it in detail yet, but I think what you did to compact
you're already here.
The messages was fine. Yeah, I mean, what you did to compact the messages is a good idea, but I haven't looked through the pull requests in detail yet. I haven't had time this week, but I will.
Cool.
I mean, otherwise, were there any other big changes structurally, or was it just changing the size of the messages?
No, just changing how things are packed in the buffers.
Yeah, I expect that's fine and a good idea, but I'll look at it closely.
And a bit of a cleanup of the periodics. I put like the rotation thing in a function too.
Yeah, I saw that. I thought that's a good idea also. And once I saw that you did that, I wanted to say I made functions like that at some point and I didn't use them, or there might. I'm wondering if I have a redundant thing somewhere in the code for the rotation. Did you see anything like that?
No. Why would that be in the geometry?
I need to look.
Maybe you had it in a branch and didn't commit it.
It could be that yeah, it could be. I'll look. Yeah, and then
yeah, the MPI comms branch is 22 commits ahead of master, so it might have something extra. I don't know.
Yeah, I don't think I had any MPI stuff that I didn't want to merge into a master that's not there. So that is probably old, but I could have done it in one of those branches and then left it. Anyway, it's I think also a good idea. Yeah, anything to simplify those routines, the better. There's still I'm still not 100% happy with those routines just because they have big switch statements, and I think there's probably eventually something we could do to divide them up a little bit more, but anyway, it's much better than it was, where it was through each of the solver classes, like same routine repeated 1,000 lines or something. So it's
Yeah. I mean, at least it's easy for, if someone wants to add something to be communicated, it's straightforward. It's all in one or two places, and you just add something to the big switch statement.
Yep.
So in that sense, it's kind of easy to understand.
Okay. Yeah, I mean, I'm also fine with this pull request actually. I mean, apart from the comments that I gave you already.
Yeah, I don't know if you noticed, but yesterday after you comment on that, I standardized the begin passive and passive.
Yeah, I saw that. Yeah.
So
yeah, I also always wanted to do it like that because I don't like having all these preprocessor statements. But yeah, it's good that you did it now.
Yeah, I didn't use. I had to make it slightly different. So I didn't use this status static variable that was in the AD. So because that was not really compatible with the way we used with the way we do that kind of logic in some places.
Yeah. So does it mean that we can remove that other approach? So with this variable there, is it still used?
No, I removed it.
Okay.
Entirely.
Okay.
So the begin passive returns a boolean, and then that boolean is passed back to the end passive, and with that we can replace or we can standardize all the places where we were doing this start stop logic.
Yeah. Okay. In theory, probably it's also possible to put it somehow in a scope or something like that, right? I was thinking about that, but it's probably a little bit more complicated to do it like that.
To put it to what? Sorry.
Yeah, so that you have like begin something, and then you open the braces, and then everything in braces is in this passive region. I guess you can do that somehow with some lifetime of an object or something like that, but it's probably a little bit of an overkill.
Yeah.
It's just nice to play around with these things, but we don't have to do it. It's just something.
Yeah,
I
think in not C++ 11 you can declare things in if statements.
Yeah.
So you can initialize things in an if statement, like in a for loop, for example.
Oh yeah, I saw that. Yes. Yeah.
Yeah, but I mean, I think it's okay like that.
Yeah, it's totally fine. It's just that some weird things can happen if you forget the end statement, for example. But okay.
Yeah, that's what was happening when I just did search and replace with the function, because it was using this global variable, and in some places we only begin passive conditionally. So it's with the global variable, it was creating some. It was missing the the start and the finish of the passive in some cases.
Yeah. Okay. Yeah, I think that makes sense that you solved it like that.
So like this, you're always forced to pass it something that should come from the begin passive. So I think you're less likely to forget.
Yeah. Good, yeah, then I'm happy with this PR at least. Okay. Yeah, so Piri, you already commented on this on the unit test thing there. I mean, this was just an idea that I have. I don't know if someone else already looked at that. The problem is that we cannot really use like really fine-grained unit tests because of the structure of the code. It's not possible. So we have to find like an intermediate way between like a regression test and a unit test, and that's what I came up with. So if anyone is interested in that.
So for this one, you just create you just use the unit quad and then check the properties of the things that it creates, right?
Yeah, exactly. It's I'm not that happy with it at the moment because all the test cases in this one file, they depend on each other, and that's not really that nice actually. So maybe I will move all the checks to one test case. I think that's more reliable.
So, Tim, I think it's perfectly fine that we do it the way you're doing it. I mean, you have to build some kind of geometry class to check things. So this is, I think, perfectly fine. I wouldn't feel bad about that. If you want, you could, I do agree that keeping them separate would be nice and kind of grouping them, for each method. So maybe you could just reconstruct. I know it's a little bit wasteful, but reconstruct the geometry in each of the subtests so that they're independent, just in case, so you can tell something broke in a specific test.
Yeah, I mean that's what I planned actually. This is why there is in this unit quad test there is already an init geometry routine that does all the initialization.
Some of these things need to be called in order, right? You cannot the individual things you're doing, like set control volume, set coordinates.
Yeah. So all these separate tests in the C geometry test file, they depend on each other. So they have to call it in this exact order that they appear there.
Yeah.
This is also the default how Catch like runs the tests, but you can pass it an argument that it randomizes the order, and that won't work, of course.
Yeah.
But if you have like another test that uses the geometry, then there is a routine that does all of this init at once already. So they then, of course, also kind of depend on each other, but yeah, there's no way around that. And the idea would be then also, sorry?
And you need a solver for this geometry test as well? That was the only thing that kind of caught my eye.
No, for this geometry test, not. No. I just added it there to this unit quad test in case you want to use it for some other test. So I want to also add like something like that for the solver classes so that you can check the gradient computation and what else.
Oh, those yeah, I've been planning to add those. Those you can check without the solver.
Oh, they don't need anything from the solver?
Yeah, those functions you can call them without the solver.
Yeah, okay. Then for this function, it's actually even better. Yeah.
You need the geometry and actually and they're templated, so you don't even, you can pass it a function object as the input. You also don't need variables or anything. You can give it just an object with that takes I point and I variable and return something. And yeah, so you can define some elementary function and check that it returns the right gradient for constant or for a plane or.
Oh, that's even better then. Yeah, okay. But there might be some other solver routines that require an instantiation of the solver.
Oh yeah.
And for these ones, it would make sense to have this solver available in this quad test case there. Yeah, and the other drawback is, of course, that we only test like hexahedral elements, because that's the only thing this mesh generator can do.
Yeah.
But at least it's a beginning.
Exactly.
Yeah, Tim, we used to have, I think we deleted it, but we used to have a divide elements routine. Do you remember that? Where we could take any mesh and divide it into tets. We could try to dig that out and try to apply it even to the box grids, at least to get tetrahedra tested potentially.
Maybe that would be an idea, yeah. But I think that most of the geometry routines are actually independent of the elements.
Yeah, most of it, yes. All the dual grid stuff should be. The pre-processing of the primal elements, there are some specific routines that sort of group all the elements and communicate them around. But that's a pretty small portion of the code. I mean, it would be good to test it, but I don't think it's at a huge risk.
Yeah, okay.
The important thing is that not a lot of it, I think not a lot of it is kind of shape specific, right? Even for the primal, even what is done for the primal elements.
No, not much. Basically, yeah, it's just like data movement stuff that's divided by element type, and then we do check the different elements for like consistency in the ordering of the elements.
The orientation
volume.
is element specific. Yeah, that's right.
Yeah, which that could be something good to look at, because that I think is a little bit of a pain point. I mean, what we have works, but like prisms always seem to be a problem. Like those are almost always out of order. Or well, there's a different ordering that's very popular for prisms that people use. It's not the VTK one that we use. So I often find prisms have to be flipped, but.
Anyway, and if you know any more test cases or any more routines that definitely need a test in geometry, then we should add them soon, I guess. Because I only added the ones that are really necessary to construct the geometry. So essentially, I just followed whatever is in the driver to construct the geometry. Yeah,
I was gonna say, I'm looking through it now. Did you basically take what was in the pre-processing routine?
Yeah, exactly.
Yeah. I mean, that's the key stuff.
And maybe we can also move these things actually to a factory or to the geometry itself, because you always have to do the same things anyway to create the geometry, right?
Yeah, pretty much. They could probably all just be private methods called from the constructor or something.
Yeah.
There might be, we should check. There might be one or two things that we need to call from outside, like whenever we update the grid, if it's moving or deforming, we need to be able to call a public function that can rebuild the volumes and a few of the other metrics.
Centers of gravity, and I think it's that it's set coordinate center of gravity. There's control volume and control bound volume.
But there is
So
already routine for that.
Yes.
Yeah, there is
I
an
just mean
update for geometry.
Yeah.
But
just
it's
not
not
move all of
reused very often.
Okay.
I actually noticed that it's not reused very often. So like the mesh solver, for example, calls the individual one specifically. And the solvers, when they restart, and it's a dynamic grid, they also call things individually. They don't call like a global or an aggregation of update geometry. So there's
Okay.
And of course, they are slightly different everywhere. Yes.
But maybe there's a way to unify them, even if there's maybe duplicate work somewhere. But we can check that. I mean,
I think the main differences are grid velocities. Some of those calls include grid velocity. Some others don't. Right?
okay, I mean, if that's the only difference, then they can be certainly unified somewhere. Okay. Yeah, but that's good already. Then we can have the testing like that, and also start building tests for the solver.
And Tim, maybe another thing, if it's easy to add, is well, it's starting to get into the realm of closer to regression tests, but it still could be interesting, is adding a CGNS file to these. So instead of just using the box, it's also trying to load a CGNS file to do the same.
Yeah, maybe we
That's
can.
more on the reader side.
Yeah.
Maybe the readers, we just need to do some unit tests for the readers.
Yeah, that's what I wanted to say. Yeah, maybe we have to do like some unit tests in quotes on these classes.
Yeah, so that could be a separate thing, and that actually would be pretty easy because those are standalone. You don't have to. They don't depend on anything else, so you could just do a test on those themselves, and then just check the public methods that feed the data back to this geometry class.
Well, I can do that already in that pull request if you want. I mean, that's not a lot of work since I'm already at the geometry. And since they build on each other, I think it makes sense.
Yeah, those ones should be easy to do independently. I think that'd be great. And we should have a really small CGNS test already in the test cases. I think I have like if you're looking for one in the incompressible files, I have it's called like laminar bend or something. It's a very, very small,
Oh, yeah, I saw
I don't
that.
even know, like 15 elements or something, size CGNS mesh that you could use for something like this.
Yeah, but yeah, okay, yeah, probably for CGNS we have to add a file, right? Just thinking whether it's possible to do it without a file, but I don't think that it's possible.
Yeah, I don't think so.
Because I don't want to like add a CGNS mesh into the unit test folder somehow.
Yeah, I have to think about that a little bit.
But I don't see another way for checking that. So I mean, it should be fine. I think. I mean,
yeah, I think it's okay.
Maybe we can also reuse it for other things. Then.
Yeah, I think it's better to test and have a small file than not test. So.
Yeah, yeah.
I might
Yeah,
have some
I
other.
can do that.
Yeah, check if that file is going to work. I might have some other small CGNS files lying around, like little cubes or boxes or something. So if you need something different, let me know. But I think that one's not bad. It's very small.
Okay. Mm-hmm. Yeah.
I'm gonna try and clean this this geometry stuff a bit.
With the updating the grid.
Yeah, because I touch these things when I so the reason I noticed this is in this thing with the communication, I ended up going through it affects the areas where these things are used. So I will try and kind of encapsulate this smaller set coordinates, set control volume, and so on, and into some larger functions.
Yeah. Did you find the ones we have? I thought there was one called update geometry or update grid or something. Is that still there?
It is, and it is still used. But then if you go to but then the mesh deformation as its own things with update multigrid and update geometry, and sometimes they are called one after the other.
I see. Yeah, we should always use the same thing. Yeah, I guess it's called update dual grid is what I put in there a long time ago.
Yeah, there's update grid coordinates, there's update dual grid. Yeah. Well, grid coordinates is specific, but dual grid could be moved to geometry.
Okay. Yeah, sounds good.
Yeah, we should also require more unit tests for pull requests and stuff like that. We also have to make sure that people add like tests, actually.
Oh, we should make sure that the code has units first.
It just depends on how you define a unit, right?
No.
This is why I created now this intermediate structure between a unit test and a regression test.
No, it makes sense. It makes sense.
Yeah, I don't think we're going to be able to do much better on the geometry. So I think what you did makes perfect sense.
Unless we refactor the geometry.
There goes Tim. There goes Tim. Refactor SU2.
Yeah. Well, but I mean, if you think about it, the geometry, those routines have to build on each other in some senses. I mean, you're only going to be able to break it down so much. Like there has to be some order to construct the dual grid, for instance. I mean,
yeah, of course.
some of the routines, yes, could be broken down to be independent. So you could just call those routines on arbitrary data, and that would be a good thing. But yeah, I'm not recommending you go spend the rest of the year on that, Tim.
I probably won't do that. I'm happy with the geometry.
I mean, we can try and make some of those things static, because the way when I was looking at those pre-processing optimizations, the routines, like the essential bits, are actually quite modular, and I think they could almost be static.
You mean the ones that are now called to construct the grid?
No, even more fine-grained than that. Let me give you an example.
Yeah, like down in the dual grid creation.
Yeah, for example, finding the common faces and or checking if two elements have a common face and those things, those kind of things. Find edge? No.
Yeah, we can certainly do that.
Yeah, you have, for example, find face that takes the indices of two elements. Yeah, it takes the indices of two elements basically, and then goes through the faces of one or the other, and finds if they have if they share a common face. That's the kind of thing that could be static if you pass it two elements instead of passing it the indices, which we could do, I guess.
Yeah, I mean, if someone volunteers. I mean, it doesn't have the highest priority though.
Yeah, I've been making everything I can static. I don't know if it's a good idea or not, but I've been making quite a few functions static when possible. But yeah.
Yeah, I think it makes sense actually.
Yeah, if it doesn't depend on anything in the class, then it's a good idea. It also makes it easier to test because you don't have to.
Yeah, exactly.
Yeah,
build a whole class.
Yeah.
Good.
I might have a couple of questions if there
Sure.
is something else. So first, a question more geared towards Tom. So I saw that at the conference, there is someone who is talking about scalar transport equations. And I wanted to know if that is somehow related to the pull request 777 from Tom, like the framework for scalar transport equations. I'm asking because that might have some influence on the work of Daniel Meyer for his flamenet approach.
Yeah, so sorry, there's a loud truck going by. Okay, it's gone. Yeah, that's a good question. It turns out that work might be related to that pull request. So we only know those folks a little bit through email, and I think we have a connection with the faculty that's on that project. But I don't actually know the details of the work, so I've just exchanged emails with them. And I did point them to that pull request a while ago, and they commented that they found it and they've been using it for that work. So I don't know to what degree or what exactly is in there. So we'll have to see. I've left that pull request open because Daniel's work, as you know, is pretty much directly built off of that. And we've discussed him putting in a pull request when the time is right, hopefully soon.
Yeah. Okay. So you don't know if they have a special branch or which they are working on, so that one could compare.
No, I don't know. So I think these are good questions for next week. Let's find out where kind of they've done the development, what exactly they've done. I know that they've found that the branch that I had started and have used it to some degree, but I can't tell you much else. That's all I know.
Okay, for now, can you just tell me what the institute is, or?
Oh yeah. We didn't post it on the agenda, huh? I'm pretty sure it's. Hold on. I wanted to say it's USC. Yeah, it's USC. So University of Southern California.
Okay. Good, thanks. Yeah, okay, it's all right if there's if you don't know exactly what they're doing, then it's not that much of an issue. Maybe it could have been that you know everything about them, so I just asked.
No, I think there are a good amount of users out there that we don't hear from all the time that, work on the code. And then, so I don't know. We'll see. I'm excited to see what they've been up to because I haven't heard much.
Yeah, cool. Then my next question is geared towards multi-zone computations, and there especially to the multi-zone option. So we have a multi-zone option, a Boolean, and that is, as far as I understand, only used for fluid cases. But from what I've now tried out, it's possible to do it basically exactly the same way with solver equals to multiphysics. So you just have to copy the solver option into the zonal configs, and that's it. So I just want to know if there's a reason to keep the multi-zone option, because from what I've seen, everything can be done with the solver equals to multiphysics way, which is then a bit easier to explain in the tutorial thingy. Because then, if once you have more than one zone, this is the way to go. So I want to know if there's a reason why there's solver or why there's the multi-zone option.
Yeah, this multi-zone option is for single physics problems.
Yes,
so
but even with single physics, you can use the solver equals to multiphysics, and it basically the files are exactly the same, but the solver options.
Yeah, but then you have to copy the solver in every of the subconfig files and stuff like that.
Yeah,
right?
it's
so it saves you that. That's the only thing. Yes.
It does something else. If you run a discrete adjoint case and you turn that option on, it will do the discrete adjoint with the multiphysics driver instead of the single zone adjoint driver.
Okay, and that works for the fluid interface cases. Okay.
That I don't know. It will take a single zone problem, but it will run it with the multi-zone adjoint driver instead of the single zone adjoint driver.
Okay. It's the same in for the direct solver.
Yeah, probably. Yeah, I expect so.
Yeah. So okay, I will.
I mean, I guess it's good for debugging if you just want to make sure that you get the same thing with that the two things are consistent. Basically, I don't know. I have a list of options that in an issue that I propose that we do something about as well. Maybe we can add more to that issue. Toby.
Yeah. Okay. Then I would try to look if there's an AD case for some sliding mesh case.
Yeah, there's not.
There's not. Okay.
At least not in the regression test. No.
Okay, because there I would guess, it's a wild guess, I know, but that the multiphysics discrete adjoint driver probably works better than the single zone one.
What do you mean works better?
Basically, it gives the correct, or it works at all. I don't know if the single zone.
The single zone adjoint solver doesn't work with multiple zones, of course.
Yeah. Okay.
This is why it's called single zone.
yeah, exactly. So I wonder what reason there could be why one would set up a fluid case, like single physics case, with that multi-zone option. What's the benefit? Except for, you spare one solver option in each zone config.
That's pretty much it, yes.
Yeah. Good. Okay, that's okay of an answer.
Well, so I would actually take that one step further and ask, I mean, do we really need single and multi? Can we just use multi-zone drivers for everything and just be able to call it with a single zone?
I don't think they have a consistent set of features yet. But I'm 100% sure they do not have a consistent set of features. Sorry.
So as in the single zone has access, I mean, it calls more things, it uses, there are more physics in there or something, and multi-zone just
Yeah,
doesn't
you can do time domain adjoints in single zone, but you cannot do them in multi-zone, for example.
Okay, got it.
Yeah, so the reason why we have these separate was that the single zone driver is much easier to understand for new people that look into the code. Because the multi-zone, especially the adjoint driver, is much more complicated. So this was one reason why we kept the single zone drivers as a separate class.
And it's a completely different logic too as well, the way it's set up.
Yeah. I mean, the single zone driver is not doing much. I mean, if you look at it, it's very simple, because all the routines mostly just forward the things to the iteration structure. So, yeah. It's just that it's easier. That's the only reason, I think.
Yeah, but it probably calls things in the iteration that would not be needed otherwise, right?
You mean, what do you mean with otherwise? In the multi-zone?
Yes. I'll try to give you an example. At least in the discrete adjoint FEA iteration as a set recording method where it actually does the recording. I don't know if the other ones have this as well.
But you're talking about the iteration structure.
Yes, I am.
Yeah, might be that they call even different things, yes.
And I know that so for the multi-zone, the recording is done entirely by the driver.
Yeah, exactly. I mean, of course, we can discuss the fact whether we want to merge them at some point or not. Of course, that would be possible. I guess. Yeah. I mean, since the multi-zone is the single zone is a special case of the multi-zone, of course, it should also work.
Yeah. Well, once all the features are there to do it that way, I guess it could make sense. Yeah.
Yeah. It's a good long-term goal.
Yeah.
Okay, I might just go on with some questions.
Yeah, keep going, Toby.
A question maybe more for you, Pedro. So there is, so we have the marker zone interface list, and we have marker CHT interface and FSI interface. But there's no fluid interface, but we do not have the FSI, like marker FSI interface, because I also reckon that that could be figured out automatically by the zonal like solver. So if you have a heat zone and a fluid zone, it is most likely to be a CHD interface. So without having looked further into that, maybe Pedro, you did you kick that option out, or because it's not needed in the FSI, so I reckon it could be at some point could be kicked out for marker CHD and marker fluid.
The FSI interface.
Yeah. So is there an option actually explicitly for the interface, or like a zone, like a marker list?
There's marker zone interface, right?
Exactly.
Yeah. And I think that's the only one I use for FSI cases.
Yeah. Yeah, so I just guessed that for CHD cases, there's an additional like one-to-one copy, I guess in most cases, with marker.
Yeah,
CHD
but that's because for CHD, those things double as the boundary condition.
Okay. Yeah. Okay, so I just.
Yeah, I think this was the reason why. I tried to make it automatic at one point, so that it is determined automatic. But I think the problem was exactly what Pedro was mentioning, that they also use as boundary conditions in the individual zones. So it was not easy to like change the structure so that it automatically sets it also as a boundary and stuff like that.
Yeah. Okay.
Yeah, because I use for FSI cases I only use marker zone interface. Is there an FSI one? If there is, it can probably be deleted.
I grabbed through the test case repository and I didn't find one, so I guess there is none. But
yeah, I think we might have some old FSI type options from the previous implementation. I deleted at least a few of them. No, I don't think we do. We have marker zone interface and marker CHD interface. Yeah.
Yeah. Okay, and then my last question, geared towards CGNS meshes, which just popped up in my head. So there is currently like all meshes which are written by SU2, especially in like a finite difference setup or a mesh or like optimization setup. If you initially provide a CGNS mesh, it will always go on with an SU2 mesh, right? Or do we have a CGNS writer?
We don't anymore. So yeah, we've never been able to run with CGNS all the way through the process. We used to have CGNS output. I think we still do somewhere in the old files, but I don't know that it's active. Yeah, okay. So that's very doable. We just so yeah, we need to put in the time to implement that. Yeah.
Okay, and for mesh morphing generally, so if you just like were to.
Oh, and Toby, sorry to interrupt, but the primary issue there is that we store the freeform deformation box inside of the SU2 mesh, which I've never been a huge fan of. If we separated that and put it in its own file, then it would be easy just to, after rewriting the CGNS mesh output, we could then do both. It would be fine. Sorry, go ahead.
Cool. Yeah, also, if SU2 Dev or if mesh deformation is currently possible in a multi-zone setup where the meshes are separated. So whenever I work with the multi-zone case and I do some mesh deformation test or finite differences, I just have like the meshes like in one mesh file, so true multi-zone mesh. So is that currently, or does somebody has experience whether that works with separated meshes right now?
I think it only writes out. I mean, you can start that mesh deformation with separated meshes, but then it writes out a combined mesh.
Okay. Yeah, because I'm asking a bit like to give some best practice kind of things. So then the best practice here would be like keep your meshes in one file, because that will that will work also if you go for finite difference mesh deformation and so on.
I would say at the moment that's the best way to do that actually is.
That's how I do it, yeah. I don't know if it's a best practice, but that's how I do it.
I mean, like best practice in terms of it gives you the least trouble because people are already doing it that way.
Yeah, well, I guess in that sense, yeah, it is.
At least the Python scripts work somehow with having one mesh file. Otherwise, there are problems, I think.
Yeah. Okay, thanks. That's it. I'm out of questions for now. Thanks.
Oh, really? Very good. Yeah, anyone else has some other questions, remarks, topics?
I have a question for Pedro. Can you hear me?
Yeah, go ahead.
Okay. So I'm exploring your framework for optimization. I don't know how you pronounce the name, Fado or whatever.
That's exactly correct, yes.
Oh, okay. Is example supposed to work out of box, or do I need to create some files or so? So the very basic example in your sources.
Is what supposed to work out of the box, sorry?
So can I just run it and see how it goes? So because I'm trying to run it and I get some exception that some file is missing, like results text file, but I don't know whether it's my mistake or is it supposed to happen, or it should work just out of the box if you run example.py from Python?
I mean, it works for me.
Okay, then probably something on my setup.
But yeah, I mean, after this or something, if you share your screen, we can try and find out what's happening.
Okay, cool. So the idea would be, I would like to understand the places. So first of all, the code, and then to try to integrate Python wrapper from SU2 to call the Python wrapper instead of the executables, just to see how it will work.
By Python wrapper, you mean Python scripts or something else?
So I'm using a Python wrapper in SU2, so just to create some simple optimization. And so far I did it only on my script. So I created a Python wrapper for SU2 dot and SU2 dev. So for single zone driver, we already have a Python wrapper, and for the discrete adjoint. So instead of calling the executables, I will just call the Python wrappers for all these SU2 classes, such that we can execute the whole optimization in memory. So for the config, I still don't have the wrapped object, but for previous mentioned things, I did something.
Yeah, we can think about that. Yeah.
Okay, then I will just contact you after, so we can arrange a meeting.
Do you want to join Giant? I don't know if he's
Giant, yeah.
Yeah. So, sorry, I'm a little bit off. Maybe a little bit.
It's still early.
Yeah. Yeah. So, I haven't yet tried out the Fado framework yet. I've been working on getting the geometry structure to be Python friendly, and I think I've gotten in line. And actually, sorry for not replying to your I was able to get
no worries.
the twig to compile finally after a lot of finagling. So there's some progress on that end. Yeah.
Okay.
All right. So maybe we set up a call after this one, and
Yeah.
Sure.
I guess this links into the like the optimization refactoring, but we don't want to drag this one for another hour.
Yes.
Okay. Yeah, I mean, are there some other questions from the audience?
Are you on Slack, Mladen?
Yes. I'll just write you a message.
Okay.
But if there are no further things, then, I mean, we made it to 1 hour. Then I would say we can stop here.
Yeah, don't forget everybody next week, Wednesday, Thursday, Friday, developers meeting. Well,
Yep.
annual meeting, users meeting, conference, whatever we're calling it.
Universal World Conference.
Exactly, the most important conference this year.
That's right.
Yeah. Okay.
Okay. Sounds good.
Then,
And I guess
I
that
don't know
means
whether
we're not going to hold this meeting next week. We'll be busy.
Oh yeah, it's at the same time. Yes. So next week we will skip that.
Yeah, I hope so. Everyone here better be at the conference.
Yes, yeah, exactly. I was just thinking whether at what time it is, but it's it's exactly the same time. So yeah.
Yeah. Sounds good.
See you then. Goodbye.
Okay.
All right.
Okay,
See you
guys.
next week.
Then
Yep.
have a nice week and talk to you soon.
Sounds
Yep.
good. Later.
Bye.
Bye.